and how it is depends upon the laws, what are the laws, what is the speciality of thermodynamics, and other than this we discuss that what is the importance of the subject. Now in today's lecture we are basically going to discuss about how how to study thermodynamics. See, not only thermodynamics, for any basic science, whenever you are going to study any basic science, then there are certain criteria, there are certain methods, right? So what are the methods available to study the thermodynamics, that we are going to discuss. Other than this, we will discuss in much detail that what method we are going to consider, and to use that method, what is basically the condition, right? So condition also will discuss everything related to how to study thermodynamics we are going to discuss today. So if audio video everything is fine, just let me know please. If audio video everything is fine, please let me know. Is it fine? I'm not able to see your chats. Right, very good evening. Yeah, now it is visible, right? Now it is visible. So can you tell me that everything is fine, audio video everything is fine? What is your name? Dukhi Atma. Your name itself is Dukhi Atma. Very good. Great. Dukhi Atma is a Hindi name, and you are in English channel, so hopefully you are good in English. So everything is fine, or any problem? Audio video everything is fine, please let me know. Audio video everything is fine. Shall we start? Okay, so let's start, right? Let's start. So today we are going to talk about how to study thermodynamics. So basically there are two ways to study thermodynamics. One is microscopic viewpoint, another one is macroscopic viewpoint. One is microscopic viewpoint, another one is macroscopic viewpoint. Not only thermodynamics, any basic science, whenever you are going to study any basic science, then two methods are basically available with you. One is microscopic viewpoint, another one is macroscopic viewpoint. Word micro itself is saying that is small, right? Word micro itself is saying that is small. So whenever we are going to study, analyze any particular system, any thermodynamic system, then the smallest part, that is molecules, right? So that molecule, if you are considering the molecular properties, in your study, then it is a microscopic approach. We all know that, right? We all know that every system, right, whatever it may be, right, whether it's solid or liquid or gas, whatever matter it is, right? So it is composed of molecules. There are a lot of molecules. It is made of molecules, right? Now in microscopic approach, we basically focus on each and every molecule that is present in the system, each and every molecule. So let's say here 20 molecules are there, so each and every molecular property will discuss, and then to find out the overall behavior of the system, we will sum up the behavior of individual molecules. Very simple. It's very simple, I would say, but it also has some conditions. Like if number of molecules are too huge, right, then you cannot use this microscopic viewpoint. I'll give you one example. For example, like I am taking one class, right? I'm taking one class. In that class some 20 students are there. I want to analyze that class, means I want to know the status of the class, right? Okay, very good evening Akash. So I want to know the status of basically class. So what I would do, I will basically ask each and every person that what is your individual status. What is your status, Akash? And Dukhi Atma, you tell me, what is your status? Facebook status? Single only? Right, because most of the mechanical engineers are single only, right? So okay, let's say some of the people, like let's say 20 people are there, so out of those 20 people, some of the people will be single, some of the people will be mingle, some will have may have some complicated relations right? So complicated part we are not going with, right? So now here two categories are there. One is single people, one is mingle people. So what I can do is I will go each and every person, right? I will go to with Akash, I will go with Dukhi Atma, I will go with Anuruddha, and what is name? Arunachal. Okay. So I'll go with each and every person and I will ask that what is your status. So some people will say, sir, I'm single. Second person will say, sir, I'm also single. Third person, sir, I'm mingle. Fourth again, single, mingle, single, mingle, right? So I'll take all the data. So how much data I have? 20 data, right? So 20 data I have. Now I want overall behavior of the class, overall status of the class. Then by using some mathematics, I can say that let's say 60% students are single and 40% students are mingle. Now this approach of analyzing the class is basically microscopic viewpoint. Means you all are molecules. 20, like suppose 20 students are there in class, so you all are molecules. I am going to ask each and every person one by one, every single molecule I am going to consider. So the individual behavior of molecule is considered in microscopic viewpoint, individual behavior of molecules. And to know the overall behavior of the system, we will sum up the behavior of individual one with the help of some mathematical technique or statistical technique. So that's why this science is also called as statistical thermodynamics. This is also called as what? Statistical thermodynamics. Now assume that I'm in some big seminar hall, right? I'm taking class in some big seminar hall where 1,000 people are there, right? Or okay, let's say 1,000 people are there. Now I want to know the status of that that seminar hall. Now it is very difficult for me to use microscopic viewpoint. Why? Because in microscopic viewpoint I need to go each and every molecule, each and every person, and ask that what is your status, what is your status. 1,000 people are there. It's very much time consuming, first thing. Second thing, I will get 1,000 data. Then I need to use some mathematical technique, right? So that mathematics is also going to be very difficult for me. So basically what I'm trying to say, this approach, microscopic approach, is useful when the density of the system is very low. Density means number of molecule present in given volume are very low. So number of molecules are less, then we can go for microscopic viewpoint. For example, like in case of solids and liquids, it's meaningless to go for microscopic viewpoint. Why? Because in solids and liquid, even if you are taking very small volume, even if you have very small volume of liquid or solid, then also thousands, lakhs of molecule will be present. So analyzing those lakhs of molecules is going to be very difficult, right? So basically this microscopic approach mostly used for gases only, and that too also not simply gases, because you already know, as per Avogadro hypothesis, 2.7 into 10 to the power 25 number of molecules are present if you are taking 1 meter cube volume, basically, right? So a huge number of molecules are present even if you are taking the atmospheric air. That is also not easy. That is also very difficult to use microscopic viewpoint. So in that case also we are going for macroscopic approach only. We are going forward macroscopic approach. So where we are using this microscopic approach? Obviously in where like we are using microscopic approach when the number of molecules are very less. For example, rarefied gases, right? Rarefied means very low pressure gases. The pressure of the gas is very huge level of vacuum is created. Huge level of vacuum means let's say cryogenic engineering, you may heard it, right? Cryogenic engineering, where we used to produce minus 170 degree, minus 200 degree temperature, right? So if you want to create such a low temperature, then you need to create very huge level of vacuum. right? Very low pressure you need to deal with. So in that case, the number of molecules may be very, very less. So macroscopic approach will not be applicable there. You need to go for microscopic approach. Clear hai? So the example of microscopic approach where you can use is that is rarefied gases. Clear hai? Okay. Sir, I understand that if 20-30 people are there in the class, then you can go for microscopic approach and you can ask each and every person that what is the status. But in 1000 students are if present, then it is not easy for you to go for microscopic approach. So what approach you are going to take and what is the method basically? What method you are going to take? How you are going to find out the status of the complete class? So what I will do is, rather than going to each and every person, I will choose simply a small volume, a small quantity of matter out of those 1000 people. Please listen here carefully again. In macroscopic approach, our attention is focused on certain quantity of matter without going the event occurring at molecular level, right? Without going the event occurring at molecular level. Okay. Now suppose this is a matter here, lakhs of molecules are there. So what I will do is, rather than going and analyzing each and every molecule, what we will do is, we will only consider a small volume, this one, very small volume, very small volume, where only 4 molecules are there. You can see here only 4 molecules are there. So now only we are going to ask those 4 molecules, those 4 people. I'm only going to ask about these 4 people that what is the status of the class. Again listen. For example, I am in seminar hall, thousands of people are there. So what I will do, I will choose any 4 student in between, right? And I will ask those 4 students that you tell me what is the status of the class. I'm not going with individual molecule, only I'm talking about those 4-5 people. So they will discuss with each other, I be single, to be single, ye be mingle, wo mingle, right? 52 are single, 2 are mingle. Okay, fine. Sir, they will answer, sir, with 2 are single, 2 are mingle, means 50-50, right? What we are getting from here, that 50% people are single and 50% people are mingle. So it clearly means that now whatever result I will get from here, I'll apply this result to throughout. पूरे में apply करेंगे. Means whatever result I will get from those 4 people, then I will assume that this is our assumption that throughout the room, throughout the seminar hall, same status is there. Clear hai? Okay. Now again I am going to tell you what is this macroscopic viewpoint. So in macroscopic viewpoint, our attention is focused on certain quantity of matter without going the event occurring at molecular level. We will not talk about molecular level. And now it is used for what? High density, like liquids are there, solids are there, even in gases also we are using the same approach. The next very important point here, individual molecule behavior is not considered. Here average behavior of molecule is considered. Clear hai? So I hope you understand the difference in microscopic viewpoint and macroscopic viewpoint, and the kind of properties which are defined for microscopic and macroscopic are also different. Macroscopic properties are very easy for us to measure, whereas microscopic molecular properties, to measure molecular properties are very difficult, because in molecular level properties are changing randomly, right? So here individual behavior is going to be very difficult to analyze, but here we are taking average behavior. So even if some molecules are changing their state, some molecules have different property changes, then that is not going to be considered, right? Only average behavior we are considering here. So I hope you understand this. Up to here everything is clear? Then please let me know once. Just make one heart, one small heart just make one small heart to show that whether you understand or not. Clear hai? Okay, fine, perfect. Now so here whatever I told, that is already written here. Whatever I told, that is written here, that matter is composed of number of molecules, and in microscopic approach the behavior of individual molecule is taken into the consideration. Individual behavior, right? So this point you need to consider, right? And the overall behavior is describing by the summing of the behavior of individual molecules. Now it is used for low densities. This is the very important point. Second is, it is also called as what? Statistical thermodynamics. It is also called as what? Statistical thermodynamics. And individual behavior of the molecule is considered. Clear hai? Any confusion? I hope there is nothing like confusion, right? So no confusion at all. Let's come to the another one, that is macroscopic viewpoint. Let's come to the macroscopic viewpoint. Now in macroscopic approach, our attention is focused on certain quantity of matter without going the event occurring at molecular level. Now average behavior of the molecule is considered, correct? And this approach is also called as what? Classical thermodynamics. So in our syllabus only classical thermodynamics are there. Only classical thermodynamics is there. In our course we are only deal with the classical thermodynamics. We are not going to talk about the molecular properties, right? We are not going to consider a molecule in our analysis, correct? Only classical thermodynamics, means macroscopic approach. Now the question is coming, what we are going to do in macroscopic viewpoint? What we are going to do in macroscopic viewpoint? So it is very easy thing. See, if I ask you that how to measure temperature, then you can easily say it's a thermometer. If I ask you how to measure pressure, then you can easily say, sir, barometers are there, manometers are there, pressure gauges are there. You can measure the pressure. So pressure you can measure, temperature you can measure, volume even you can measure by measuring the dimensions, correct na? So pressure, temperature, volume, these are the measurable quantities. Now if I ask you, can you measure the entropy of any system? No, there is no any device which can measure the entropy. Enthalpy? No, there is no such device. Internal energy? No. These are the properties, even though it is macroscopic properties, but associated with the molecules. Associated with the molecules. So so basically it's, we don't have any device. We don't have any device to measure enthalpy, or we don't have any device to measure entropy. We don't have any device to measure internal energy. So what we are going to do in this classical thermodynamics? What we are going to do in classical thermodynamics? We will develop the relation. For example, we are going to develop the relation like entropy is a function of let's say P, pressure, temperature and volume. Now pressure we can measure, temperature we can measure, volume we can measure. So with the help of pressure, temperature and volume, entropy we can calculate. Entropy we can calculate. So now I can say that in macroscopic viewpoint, we will try to establish the relation between measurable and non-measurable properties. Why? Because if you will get the relation between measurable and non-measurable properties, then measurable properties you can measure experimentally, and non-measurable properties you can calculate with the help of measurable properties. Is it fine to everyone? What are the measurable properties? Just now I told pressure, temperature and volume, right? What are the non-measurable properties like entropy, enthalpy, internal energy, etc., right? So now it is clear, now it is completely clear that what is microscopic viewpoint, what is macroscopic viewpoint, what we are going to do, right? What we are going to use, and what we are going to do in classical thermodynamics. Basically we are going to establish the relations. So in basic thermodynamics we are basically developing lot of relations with the help of different laws, like law of conservation of energy, first law, second law, zeroth law, Right. So and even number of different concepts, entropy and exergy, we are going to develop many relations, and then those relations are going to be used practically in applied thermodynamics, like IC engine cycles, power plant cycles, refrigeration cycles, correct, psychrometry, even anywhere you can use those relations, right? Anywhere you can use those relations, but you must be very much clear about the assumptions taken behind any particular equation, correct? That is very much important. Okay, now one doubt I have, right? See, microscopic approach is always correct. Obviously, suppose some 100 people are there, you are asking each and every person what is your status, so finally you will get the exact correct result. But are you sure that microscopic viewpoint will also be correct every time? Let me give you one example. For example, I am in one seminar hall, right, and thousands of people are there. I want to know the behavior, I want to know the status of the seminar hall. Then what I did is I chosen 4 people, I chosen 4 students. I asked that what is your status. Luckily they are mechanical engineers. Luckily all 4 are mechanical engineers. Mechanical engineer means single people, right? Single people. So all 4 are single. So they said that, sir, we all are single, so whole seminar hall is single. Please listen here carefully. What I'm trying to say, that if 1000 people are sitting in one seminar hall, right? Exactly, Dukhi Atma. Exactly. What I'm trying to say, not only less accurate, beta, not only less accurate. Please listen the point which I want to convey here. I have chosen 4 people. I asked that what is the status. They said that, sir, we 4 are single, so single. It means, or what was our assumption? Our assumption is whatever those people will say, whatever result we will get, right? Whatever result we will get from here, that will be applicable everywhere. That will be applicable throughout the system. Okay, sir, got it. Okay, sir, got it. So it means that if those 4 people are saying, that we all are single, it means that complete seminar hall is single. It is not correct, because in seminar hall maybe some CS guys are there, some EC people are there, even nowadays civil people also have girlfriends, correct? So basically what I'm trying to say, that our analysis is going to be wrong. In this particular case our analysis is wrong. Now you may ask one thing, sir, you are saying that you are going to use classical thermodynamics, means macroscopic viewpoint. Now you are saying that classical thermodynamics may wrong. So if it may wrong, then why you are using it? If it may wrong, then why you are using it? The answer is very simple, that it is wrong because we have chosen wrong. Listen here carefully. It is wrong because we have chosen the wrong sampling. Sir, what will do in that case? Actually, if you want to apply, please listen here carefully. If you want to apply Dukhiyatma, if you really wants to apply the macroscopic viewpoint, if you really wants to apply macroscopic viewpoint in any system, then it must satisfy, the condition to apply macroscopic viewpoint. Can anyone suggest, can anyone tell what is the condition of macroscopic viewpoint? What is the condition of macroscopic viewpoint? Anyone? Listen here carefully again. What I'm trying to say, beta, see, just now I said that we are going to use classical thermodynamics, but classical thermodynamics may wrong. Why it is wrong? Because the system which I chosen, that is not satisfying the condition to apply macroscopic viewpoint. Now my question is, what is the condition? What is the condition to apply macroscopic viewpoint? Anyone? Any guesses? Any guesses? Any guesses? Any guesses? No guesses? Any guesses? That not same number. Very good. Yes. So Dukhi Atma is not that much Dukhi, is correct, right? You are correct. The condition name is something different, but okay, you are probably correct. So the condition is concept of continuum. Concept of continuum. Whenever you are going to use, please listen this point carefully. Whenever you are going to use macroscopic viewpoint in any system, then it must satisfy the concept of continuum. Then only the analysis is going to be correct. Otherwise it will be wrong. Now question is coming, what is concept of continuum? See, you may all studied already, you may studied what is concept of continuum, but you never know that why you are studying it. Now suppose you are sitting in interview and someone is asking you what is concept of continuum, what is concept of continuum, then the first thing that you need to say is concept of continuum is the criteria. Concept of continuum is the criteria to apply macroscopic viewpoint. Concept of continuum is the criteria to apply macroscopic viewpoint. Clear है? क्या है concept of continuum? Criteria है कि आप macroscopic viewpoint को use कर सकें. If any system is not satisfying concept of continuum, if any system is not satisfying concept of continuum, it simply means that you cannot apply macroscopic viewpoint. You cannot apply macroscopic viewpoint. Is it clear to everyone? Now we are going to discuss the concept of continuum. Basically, continuum means continuous arrangement, or I would say the better word will be homogeneous without holes. Please listen here carefully again. Homogeneous without holes. I have a doubt. Please ask Weber. Please ask Weber. I am here to clear your all the doubts. I am here to clear all your doubts, beta. You can directly ask. No need to take permission from me, because I am here for that purpose only. Correct? So you can, anyone can ask the doubt anytime. No problem at all. Clear? I will definitely clear that out. So continuum means what? Continuum means continuous arrangement, homogeneous continuous arrangement of the molecules. So ideally, please listen here carefully, ideally the macroscopic viewpoint can be only applied when the molecules are arranged like this and there is no any gap. There should be no any gap. There should be no absolutely no gaps. Even this gap he is showing now, that should also be not there. So it should be complete. There should be no any doubt gap. There should be no any gap. So molecule should be arranged like this. Will the real gases also follow the concept of continuum? Yes, 100%. 100% real gas also follow. Not only ideal gas, real gas even better follow the concept of continuum compared to ideal gas. You will get to know in next to next lecture. Definitely you will get to know in next to next lecture. Clear? So basically continuum means beta, continuum means continuous arrangement of molecules. So this is the ideal case, but it is not feasible thing. then if suppose you want to looking for this type of arrangement, then you cannot use macroscopic viewpoint anywhere, because this type of arrangement you will not get. Even in solids also, molecules are not perfectly, you know, spaceless. Some space are there and they are vibrating about their own axis, right? Molecules are vibrating about their own axis. So basically even in solid also such arrangement you will not find. So people made some criteria, so that criteria we need to discuss. Ideally it should be like this, right? But I'm not talking about ideally. Actually, what is the criteria? Actual criteria is something different. So that we need to discuss here. Clear hai? Actually, you may studied, right? You may study that properties are point function or state function. Means properties can be defined at any point in the system. Sir, continuum was studied in fluid. Oh, great, Dukhi Atma, great. If you studied, then it's very, very good. Maybe here some students may be there who did not gone through fluid mechanics yet, so maybe they don't know. So that's why I'm teaching here. So no problem. You will get. You can revise it, right? So, okay. So up to here, if everything is clear, up to here, if any doubt is there, you can ask, right? So concept of continuum you understand. Now I'm going to tell you the exact criteria. Achha, one point I was saying that properties are defined, said as a point function, means it can be defined at any point in the substance. But please listen here carefully. Suppose molecules are like this, right? Molecules are like this. So how can it be a point function? Because if you are measuring the property at this particular location, then here there is no molecule. If there is no any molecule, then how you will measure the property? So basically, if a particular substance, please listen here carefully, if a particular substance is closely packed, then only you can say that the properties are state function for that particular material. But closely packed is not possible, then at least they must satisfy the criteria of concept of continuum. So if any substance is satisfying the concept of continuum, then only we can say that properties are state function or point function. Otherwise you cannot define the property at every single point. Clear hai? Perfect. Now let me explain that what is concept of continuum. So let's say I have one system, right? This is our system. Now this system is composed of number of molecules. So here lot of molecules are there, right? Lot of molecules are there, right? Lot of molecules are there, right? Perfectly fine. Now I want to analyze this system with the help of macroscopic viewpoint. So what I would do, I will consider a small volume. Right, I'll consider the small volume. Let's say this is the volume where 4 molecules are there. How many molecules are there? 4 molecules are there. The mass of this is small quantity is dm, and the volume of this one is dv. So if I measure the property at this particular location, forget about all other things, only focus on here. So in this particular case, I can say rho is equal to dm by dv, mass per unit volume. So this is basically the rho we can define for this one. Clear hai? We can define rho like this. Now please listen. So now I can represent this. So this is the rho I am representing here. This is the rho, dm by dv. Right? So this is rho, basically dm by dv. So dm by dv we are defining like this, rho. Now now we all know that molecules are in random motion. Molecules are in random motion. If molecules are random motion, then there may be chance that one molecule may go out. Suppose this molecule is there, this molecule may go out. That is one possible condition. So if this is the condition, in that case what will happen? The mass of the system is going to be decreased, because earlier 4 molecule was there which are contributing in the mass. Now only 3 remaining, because one is out of the system, because they are random motion. Clear? So now only 3 molecules are there. So now mass will decrease by 25%. If volume is same, so volume is same, mass is decreased by 25%, so density will also decrease by 25%. So now density, earlier I measured this one, but if one molecule, if one molecule will go out, then density will decrease and it will reach here somewhere. What is in this axis? I'll tell you. Just wait. In this axis basically rho is there. Okay. Now what I am going to say, this is the one possibility, beta. This is the one another possibility is, rather than coming out, one molecule is entering. Now total how many molecules are there? 5. Now how many molecules are there? 5. Now if 5 earlier 4 molecules were contributing for the mass, now 5 molecules are there. So the mass is increased by 20%. So mass is increases. So mass will increase means density will also increase. So density will also increase. So these two possibilities are there. Even if one molecule will go out or one molecule will enter, then this fluctuation will come in the density. But sir, you told, I'm not like you told, sir, you told that in case of macroscopy viewpoint, there should no any effect of molecules. Molecule का effect नहीं होना चाहिए था. You said that in case of macroscopy viewpoint, there should be no any effect of molecules or molecular properties. But here effect is there. If one molecule is going out, then density is decreased by 25%. If molecule is one molecule is entering, then density is increased by 25%. You are getting my point or not? Yes, sir. It means that this analysis is not appropriate. Okay, sir. So what to do in that case? What we can do? What you can do is, you can basically increase the size of this. Actually, this whatever size you are considering, whatever quantity you are considering, that is very, very small. Whatever quantity you are considering, that is very, very small. That is very, very small, right? And if you increase this volume little bit, the number of molecule inside the system will increase. Let's say now 2000 molecules are there. If 1-2 molecule will go out or 1-2 molecule enter, is there any significant change in density? No, because 2000 molecules are there. Few molecules, 2, 3, 5, 10 molecules are went out, then also there is no any much change in the mass. So density change will also be negligibly small. So what I'm trying to say now, in this axis I am representing dV. dV means what? dV means the volume which we are considering. When I consider dV as this one, then huge fluctuation is there. Now if you are increasing the dV, the number of molecule inside this small volume will increase and fluctuation will decrease. So this fluctuation will decrease. After some time it will be like this. So now this is actually, I will call it dV dash. We called as a dV dash. Clear hai? Now if, please listen, this is the criteria of continuum. This is the criteria of continuum basically. Now if the volume which you are considering, means the volume which you are considering, if that is bigger than this one, then continuum will be satisfied. If it is less than this one, then continuum will not be satisfied. Clear hai? Is it clear? So this region I can say it is a domain or area, domain of continuum, domain of continuum, and this we call as a domain of molecular effect, right? Domain of molecular effect. Clear hai? Sir, we can say that dV tends to 0. If dV tends to 0, let's say in some system, acha ye dV dash is not fixed value. For every system this will be different. You are getting my point or not? Maybe this dV dash will be very small in case of solids. In case of solids, this dV dash may approach to the 0. Whereas in rarefied gas, it may be very huge. Even it may be greater than the system itself. Suppose you have this much size of container where you want to do the analysis, and it's a rarefied gas. Only few molecules are there inside the container. Now, as per analysis, dV dash is more. This is, let's say, half meter cube. Now as per analysis, dV dash is coming 0.7 meter cube. In that case, you cannot use macroscopic viewpoint. You have to go for molecular way. You have to go for this microscopic viewpoint. Clear hai Dukhi Atma? No, dV dash is not tends to 0. Because if it will go in this side na, then continuum will not satisfy. Clear hai na? It should be more than that. dV dash should be more than, like the volume which you are considering, that should be more than this one. Clear hai? Is it clear? Now I'll give you one example. See, whatever analysis we are doing beta, Dukhi Atmas, तुम्हारे लिए सिर्फ बता रहा हूँ. This explanation is only for Dukhi Atma because I want to make him happy Atma, right? So after I am going to explain something, right? And after that explanation, if you are happy, then change your name to Happy Atma. Okay? Happy Atma. Okay. Now I am going to tell you that how we are using macroscopy physically. People get to know the definition that in macroscopic viewpoint our attention is focused on certain quantity of matter without going to blah 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 blah, but they are not physically able to visualize how macroscopic viewpoint works, how macroscopic viewpoint actually works. Okay, I'll tell you, don't worry. Let's say you want to measure the pressure. How you will measure the pressure, Dukhi Atma? How you will measure the pressure, beta? Very simple. How you will measure the pressure? Suppose you have this container, right? And here you want to measure the pressure. So how you will measure? Obviously, you will use some manometer, right? You will use some manometer. Now I am going to use some manometer. I am going to use some manometer, U2 manometer, for example. I am going to use one U2 manometer. In this U2 manometer, obviously some manometric fluid will be there that will be displaced. So this is a manometric fluid. Okay, this is, let's say, H height, and here we have this is the gas or fluid जिसका pressure measure करना है. This is the gas whose pressure I want to measure. Now my question is to you, Dukhi Atma. My question is to you is, right, my question to you is, Dukhi Atma, is complete fluid is participating in the measure of pressure, right? See, as per microscopy viewpoint, each and individual molecule should be analyzed. In macroscopy viewpoint, only few molecules, certain quantity of matter is going to analyze. So my question, this is the total number of molecules, total system. Is complete system is participating in the measurement of pressure? No, only few molecules, only these molecules are actually participating. So this is the small molecule, this is the small system, not complete. In complete system, only small part we are choosing here, only a small part we are choosing here too. Very small part we are choosing here to measure the pressure. Means whatever pressure you are going to measure from here, that pressure is basically macroscopic pressure. Okay, fine. So this is the way. Not only this one, any measuring device, maybe thermometer, maybe anything you can take, right? So those are basically, suppose you want to measure the temperature of your body, and you are taking one thermometer. So are you going to use thermometer like this, here temperature, here temperature, here temperature, here temperature, here temperature, here? No, you are only you are putting like this, or you are holding like this, for example, right? So is your complete body is going to measure the temperature? No, only some part, only hand is actually this part, right? Only hand is coming to the contact. So whatever temperature I'll get from this hand, I'll assume that whole body has the same temperature. This is a macroscopic viewpoint. You are getting my point? Is it clear? This is the meaning of macroscopic viewpoint. Clear है बेटा? इसमें कोई problem नहीं है, right? So whatever devices we are using, those are not microscopic devices, those are macroscopic devices. In macroscopic viewpoint, I said that our attention is focused on certain quantity of matter. What is that certain quantity of matter? Let's say you are measuring the temperature, then only certain part you are using. Now only this part you are using for analysis. Complete body is not taking part. Here also, complete fluid is not taking part. Only this is taking part. So this is what type of study? Macroscopic study. This is what type of study? Macroscopic study. Very good. Perfectly fine. Absolutely. Now I am going to tell you one most interesting fact to the Dukhi Atma. I want to tell you one most interesting fact. You may studied in fluid mechanics, as you are saying that you already studied fluid mechanics. So I would like to ask one thing. That you may studied the diameter of U-tube manometer must be greater than 1 centimeter or 10 mm. The diameter of U-tube manometer must be greater than 1 mm. 10 mm, right? The diameter of U-tube manometer must be greater than 10 mm. Why? That is my question. Please listen the question again. My question is, you may studied in fluid mechanics that the diameter of U-tube manometer must be greater than 10 mm. My question is, why it should be greater than 10 mm? Any idea, Dukhi Atma? Any idea, Dukhi Atma? Otherwise capillary effect will come. Very good, Dukhi Atma. Now the next question to you is, why capillary effect is coming? Because of adhesive and cohesive force. Now adhesive and cohesive force is a molecular force. इधर देखो, इधर आओ दुखी आत्मा. For example, if you are making very small tube, it is 1 mm diameter, very small tube. Now you are taking very small tube for pressure measurement. Right now if you are taking very small tube in pressure measurement beta, in that case how many molecule, let's say this is a system, right? So here some gas is there, right? So how many molecules of the gas are coming into contact with the mercury? How many molecules of the gas are coming into mercury? That is very less. Only few molecules are coming. Only few molecule means this portion is very small. This portion dv is very small. When dv is very small, means less than dv dash, then what will happen? Molecular effect will increase, molecular effect will dominate, molecular effect will dominate. अरे इधर देखो बाबू, इधर देखो बाबू, देखो, if you are making very small youtube, very small youtube, very small youtube, then the number of molecule which are coming into the contact with the mercury, that are very less, very less. Only few molecule, let's say 5-10 molecules are coming into the contact. 5-10 molecules, 20-30 molecules are coming into the contact. In that case what will happen? Pressure is what? Normal force per unit area, normal force per unit area, but that pressure force is basically related to the molecular momentum. So here whatever molecular property, molecular forces like adhesive force and cohesive force will dominate. Adhesive force and cohesive force will dominate. So that effect, adhesive and cohesive force effect, will be more, and because of that capillary rise or capillary fall will take place. Clear hai? Now in this case, when the number of molecules are huge, let's say here 2000 molecules are coming into contact. If 2000 molecules are there, then they all that molecule will exert some pressure, and correct pressure will be measured. Because now in this particular case, when the YouTube manometer will be more than 10 mm diameter, in that case the number of molecules will be more. If number of molecules will be more, if number of molecules will be more, तो क्या होगा? In that case the molecular forces, molecular properties will very less, molecular properties will very less. So there will be no any capillary effect or something. So now onwards, Dukhi Atma, suppose you are sitting in interview, you are sitting in interview. Now they are asking that now they are asking, for example, you are sitting in one interview, they are asking that why the YouTube manometer diameter must be greater than 10 mm. Then don't say because of capillary effect. Why? Because out of 10 people, if same question were asked from 10 people, then 9 people will answer the same thing, capillary effect. Now what you need to say? You have to say that, sir, because it will violate the criteria of concept of continuum, uska halat kharab ho jata. Now what you need to say? You need to say that no, he will start listening you, seriously, that all 9 people are saying it because of capillary effect will come, capillary, but you are saying that the criteria to apply macroscopic viewpoint, that is concept of continuum, will be violated. In that case he will ask you, what is concept of continuum beta? Now if you explain concept of continuum like this, believe me, he will select you. Clear है दुखी राइट? मेरा हालत खराब हो गया, व्हाट अ कॉन्सेप्ट. तो दुखी आत्मा, वेरी गुड, कह रहा मेरा हालत खराब हो गया. दुखी आत्मा, अभी तो कुछ नहीं हुआ है, ये तो ट्रेलर है. दुखी आत्मा, दिस इज अ ट्रेलर. नाउ यू चेंज योर नेम बिकॉज यू प्रॉमिस्ड that you will change your name, right? So now you need to change your name and put it as a happy atma, because in my class it is a happy. Be happy. Okay, okay, great. Now Dukhi Atma, you will ask one thing. Okay, after class you can change, no need to change now. So tomorrow I think no class is there. Day after tomorrow, let's see whether class is there or not. So whenever next class will be there, I want to see you with a different name, that is happy Atma. Okay, right. रैंक आने के बाद चेंज होगा सर, क्या बात है, वेरी गुड, ग्रेट, appreciated. Okay, let's talk about one more thing. Now suppose you are asking me, sir, how I will check? Please listen here. Suppose if you are asking me, sir, how I will check whether the concept, whether a particular system is satisfying the concept of continuum or not, right? If suppose you are asking me, sir, how I will check whether the concept of continuum is satisfied or not, then I would say there is one criteria that is known as Nudsen number. But it is not required to check for solid and liquids. Please listen here carefully. In case of solids and liquid, please listen here carefully. In case of solids and liquid, even if you are considering very small volume, then also huge number of molecules will be there. So we can say that in case of solids and liquid, concept of continuum is always satisfied. Only in case of gases you need to check. So how we will check in case of gases? Check in case of gases? That is Nudsen number. This is basically whatever I teach up to now. Nudsen number I'll tell you, don't worry. Nudsen number is a ratio of mean free part to the characteristic dimension. So I'll explain you what is mean free path, what is characteristic dimension in detail, don't worry. So here whatever I teach up to now, that is written here so that you can make your own notes, right? So I told you that continuum means what? Continuum means homogeneous matter without holes, with no holes, correct? And it is a criteria to apply macroscopic viewpoint. So in macroscopic viewpoint, we always concern with the volume which is very large compared to the molecular dimension. See, actually in macroscopic viewpoint we are considering very small volume, but that volume will be seems like very small, but actually it's very big compared to molecular dimension. It should be very big compared to molecular dimension. Okay. Okay, so even a very small volume of the system may contains very large number of molecules. So if large number of molecules will be there, then only statistical averaging will be meaningful. जो हमने बोला ना, in classical thermodynamics or macroscopic viewpoint, average behavior of molecule is considered. So average behavior, this averaging will be meaningful or correct only when the number of molecules present in the systems are huge, right? So that criteria is what? The criteria is, right? Acha, next point I can say that what concept of continuum is basically giving? Concept of continuum is giving the minimum volume, this one dv dash, right? This volume dv dash, it is giving the minimum volume that you need to consider so that averaging is meaningful. Now I told that for solid and liquid it is always hold good. What concept of continuum? For solid and liquid, concept of continuum always hold good, but for gases, especially low pressure gases, it is not always so true because the distance between the molecules are huge. I will tell you. So we can check whether the concept of continuum is valid or not with the help of Nudsen number, right? With the help of Nudsen number. Now what is Nudsen number? Nudsen number is the ratio of mean free path to the characteristic dimension. Can you tell me what is characteristic dimension, Dukhi Atma? Can you tell me what is characteristic dimension? What is characteristic dimension? So if Nudsen number value is less than 0.01, 0.01, then continuum is valid. Length traveled by molecule, no, that is a mean free path. I'm not asking the mean free path. That is mean free path, beta. You are saying for mean free path. I'm not asking for mean free path. I am simply asking what is characteristic dimension. Mean free path, okay, I'll tell you. Mean free path is a distance traveled by a molecule between two successive collisions. Suppose here lot of molecules are there, right? Lot of molecules are there. Now one molecule is going to collide with another molecule. Then after some time it is going to collide with another molecule. After some distance it will collide with another molecule. So the average of all these distance is actually called as mean free path. So mean free path, mean free, सर V by A यही जानता हूँ बस, ओके कोई बात नहीं. So mean free path actually represent the distance between the molecules, right? It is the method, ध्यान से समझिए दुखी आत्मा. Mean free path is the method to find out the average spacing between the molecules. Mean free, क्योंकि molecules तो move कर रहे हैं ना, right? In actually in gases molecules are randomly moving. Then how you will find out what is the spacing? I just want only one thing, what is the spacing between the molecule? So every molecule, between every molecule spacing is different, even they are moving. So method is coming like mean free path. Mean free path means when two successive collisions are there, then between these two successive collisions, what is the distance traveled? And that is basically representing the distance between, suppose one gas is rarefied, like only few molecules. Suppose in your room 100 molecules are there. 100 molecules are there, then when they collide with one, then to collide another one, more distance it have to travel. If thousands are there, then less distance it have to travel, right? So more dense medium means small mean effective sorry, this, okay. So mean free path. So if more dense medium is there, means small mean free path, and if rare medium is there, means big mean free path. That is the one thing. Now the next point, beta, next very important point, this is basically continuum constant. Now next is characteristic. Let's see, in a particular substance, in particular device, in particular system, many dimensions are there. X dimension, Y direction, ye length, ye width, phalan, dema, time, right? So lot of dimensions are there. In a particular system, lot of dimensions are there, but there is one dimension in which major property changes are there. For example, suppose pipe is there, right? In case of pipe, what is the characteristic dimension? That is diameter. Why diameter? Because if you compare with length, in length also properties are changing, but in diameter the change in properties are huge. See velocity profile, right? So here if you see, the velocity changes are very huge. So characteristic dimension will come what? Characteristic dimension will come basically the diameter. Are you getting my point or not? Means characteristic dimension is a dimension in which the major property changes are occurring, correct? And to calculate that mathematically, you are saying correct, that characteristic dimension, right, LC is equal to volume of the body to the surface area, right? Surface area, clear hai? Volume of the body to the surface area of the body, volume of the body to the surface area body, right? So इनका ratio निकालेंगे. If that ratio is less than 0.01, then only we can use concept of continuum. Then only we can use concept of continuum, means then only we can use macroscopic viewpoint. So this is all about macroscopic viewpoint and microscopic viewpoint and how to study it. So I hope you are, sir, vacuum is possible. See, vacuum is different, beta. Evacuated is different. You just modify your answer. Vacuum does not means that no molecules. See, suppose this is the atmosphere. Here pressure is atmospheric pressure. This is PATM, right? This is PATM, right? Here this much molecules are there. Now what I'm going to do, now I remove some of the molecules and throw it out. Now only few molecules are there. Now this is vacuum. Now this is a vacuum. Vacuum means pressure is less than atmospheric pressure. Vacuum means less than atmospheric pressure. That is clearly possible. And you are actually saying evacuated. Evacuated means no molecules. Evacuated, this is not feasible. This is not feasible to make in any container, right? To make is evacuated, completely evacuated is very difficult, right? Infinite amount of work is basically required to evacuate it. That is not possible at all. So this theoretically it is possible, but practically it is not possible. That evacuated tank, evacuated means no molecules are there, whereas this is a vacuum. Vacuum means molecules are there but pressure is less than atmospheric pressure. And this is PATM, you already know. Clear hai dukhi atma? Are you happy? Are you happy little bit? Are you little bit happy? If any other doubt is there, you can ask. Otherwise we'll stop today's discussion, and next class we'll discuss some of the most important basic concepts of thermodynamics. Happy, very good. Dukhiya, if one student is also happy because of whatever little bit knowledge I gain up to now, whatever experience I gained in last 13 years, 12 years basically. So in last 12 years, whatever experience I got, because of that experience, even as if a single student is also going to be benefited, my job is done. My job is done, right? So before leaving the session, I would like to request everyone to make one heart. Even if you are watching it offline, and then also before leaving, just make one dil. Just make one heart. You just have to make one heart, and then you can go. And we will meet soon and discuss few of the very good concepts, right? My name is Shivam. I did my MTech from NIT Calicut. After that, I got chance to work with Indian Oil Corporation Limited. Sir, any batch? Sir, all thermodynamics is going? Yes. Complete thermodynamics I will cover here. Nagaswamy Iyer. Yes, Nagaswamy Iyer. I will complete all the thermodynamics. Don't worry. But it will take time. I can tell you first. Sir, any dropper batch is there? Yes, dropper batches are there. Even Parakram batch is a dropper batch. Parakram batch, which is designed for GATE 2024, that is a dropper batch. You can use it. And if you rank in last year if your rank is 3000 nearby or less than 3000, if your rank is less than 3000 or something, then I'll suggest you to join Vijay batch. Vijay batch is actually rank improvement batch. Vijay batch is a rank improvement batch. Vijay batch is a rank improvement batch. Parakram 2024. Parakram batch for 2024 is basically dropper batch. And Shreshth 2025 is basically college going student 2-year program batch. So 3 batches are there, 3 categories are there, Dukhiyatma. Anyone you can join, no problem. One is Vijay batch, right? Gate नहीं दिया है but तैयारी full है. अगर तैयारी फुल है तो तुम विजय बैच ज्वाइन कर लो, बिकॉज इन विजय बैच व्हाट वी आर गोइंग टू डू, वी आर basically more focusing on difficult questions. In Parakram batch we are starting with a very basic questions, like every single type is easy to easy question also solve, tough to tough also will solve. But in Vijay batch we'll basically start with little bit medium type of questions, and even in concept also we will try to make it crisp. We'll try to make it crisp, and we are assuming that you know little bit mathematics, little bit knowledge you have, so that we are considering in Vijay batch. So if you are taking Vijay batch, then it will consume your less time. It will consume less time, and its price is also less, I think 3000 only, right? Price is also less. Yeah, मैं ही पढ़ाऊंगा. I will only teach in both the batches. I will teach only. I will only teach. Sir, I forget the ID at the exam center. अरे, oh my God. कोई नहीं, मैं ही पढ़ाऊंगा. मैं भी पढ़ाऊंगा, पूरा टीम पढ़ाएगा, right? You will get best possible content available in the market, and in best affordable price, best possible quality and best possible price, best possible quality in best possible price. I think Vijay batch is only 3000 or something, I don't remember exactly, and this Parakram batch is only 5-6,000 rupees only. Okay, शायद मिलते हैं तुम. अरे कल ही आ रहे हो? चलो ठीक है, कल मिलते हैं. लेट्स मीट टुमारो. बाय बाय. हाँ मैं ही पढ़ाऊंगा भैया, बोल दिया ना, मैं ही पढ़ाऊंगा. तुम आ जाओ, आ जाओ, चाहे पराक्रम में आ जाओ, चाहे विजय में आ जाओ, कोई दिक्कत नहीं, मैं ही पढ़ाऊंगा. चलो लेट्स मीट. इंग्लिश वाले में आना. तुम तो हिंदी जानते हो ना, अगर हिंदी जानते हो तो इंग्लिश वाले बैच में आना. अगर हिंदी जानते हो तो इंग्लिश वाले बैच में आना, ठीक है? सर मैं आपको इंस्टाग्राम पे क्वेश्चन भेज सकता हूँ? हाँ भेज देना. इंस्टाग्राम में ढूंढ लोगे मुझे? पता नहीं, मैं ज़्यादा एक्टिव नहीं हूँ यार. टेलीग्राम में पूछ लेना, नाम याद रहेगा, नाम यही रहेगा. इंस्टाग्राम में तो नाम तो यही है, लेकिन इंस्टाग्राम में मैं ज़्यादा एक्टिव नहीं हूँ यार. तुम टेलीग्राम में पूछ लेना. शिवम दीक्षित, शिवम दीक्षित टेलीग्राम में ढूंढोगे मिल जाएगा. या फिर पीडब्ल्यू का जो ऑफिशियल वो है, क्या कहते हैं, चैनल है, मैकेनिकल डिस्कशन फोरम, वहाँ पे भी पूछ सकते हो, कोई दिक्कत नहीं है, ठीक है? चलो थैंक यू वेरी मच. राइट, थैंक यू वेरी मच. बाय बाय, गुड नाइट, गुड नाइट. ढूंढ लिया आपको सर? अरे इतनी जल्दी ढूंढ लिया. यू आर वेरी एक्टिव यार, यू आर वेरी एक्टिव. थैंक यू. चलो मिलते हैं कभी. ओके बाय बाय, गुड नाइट, गुड नाइट, गुड नाइट एवरीवन.